So first of all, we know something's an exponential equation when what we're trying to solve for, the variable, is in the exponent. So anytime the variable is in the exponent, it makes it an exponential equation. And up till now, we've looked at two strategies for solving these. One was using our powers chart. If we could get things as the same base on both sides, then we could solve that. Now that was helpful for a question like this, because you could write both the 4 and the 8 as powers of 2. Now if we couldn't write things with the same base, another way that we solved these was by typing one side of the equation into y1 and the other side into y2 and finding out where they intersected on our graphing calculator. Now, we're going to learn today a third way, which is the algebraic way. And the algebraic way of solving for x in an exponent uses logs. So as far as steps that we're basically going to follow each time, the first step in an exponential equation is that we're going to take the log of both sides. All right, take log of both sides. That's often going to be a first step. And then your job is to use your log laws to move the variable. I'm just going to put x in brackets. We're going to use our log laws to move the x out of the exponent. Once we've moved our x out of the exponent, then we are going to use our regular algebra to solve for x. But in some cases, we're going to have to use factoring and algebra techniques like that. So these are basic steps that we're going to take for solving exponential equations. So here's our first exponential equation. And 2 to the x equals 3 if we take the log of both sides. And generally, you're going to get used to taking the log of both sides. We can also take the natural log of both sides. Those would be the two most common ways to solve this, by taking the log of both sides or the natural log. You could take the log of base 401 if you wanted to, but it takes more writing. And putting into your calculator later will also be more tiring. So we'll take the log of both sides. At this point, we've done step 1. Step 2, can we use log laws to move our x out of the exponent? Yes. In this one particular, we can move that x right now in front using that log law. And we get x log 2 equals log 3. Now the third step, use your algebraic knowledge from before to get x by itself. Right now on the left, it's x times a number. And on the right-hand side, we've got another number. We have to remember that log 2 is a number. Log 3 is a number. Log by itself doesn't mean anything unless there's a number or something inside of it. So at this point, if I wanted to get x by itself, I could divide both sides by log 2. And we get x equals log 3 over log 2. Now, the really nice thing about exponential equations is they're always calculator, unless you were asked to leave your answer like this. But usually, they would like an answer to this as a decimal. So if we take out our calculator, we can type in log 3 divided by log 2. And we get an answer. So x is approximately 1.58. Now, the nice thing about your calculator is if you plug in an answer, you will be able to tell whether you should get this question right or not. You can take that answer and plug it back into the original equation. Two ways that you can go about doing that. One, the original equation was 2 to the x equals 3. So I can just go 2 to the power and collect my answer from before and see, does it equal 3? If it does, then I know I've got my answer completely right. Sometimes, I'm going to show you another button. I'm going to retype this in. Let's say you just got that answer, 1.58. Sometimes it's going to be really helpful to store that answer. So above your on button is the store button. Store that answer as x, because then you can check what is 2 to the power x. Does it equal 3? Yes, it does. And that's going to be really helpful if we've got an equation where there's an x on both sides, and we'll see one of those in a bit. So the nice thing about an exponential equation, solving it with your calculator, you've shown the algebra of how to get it. Once you get that answer, you can always plug it back in and tell if you're going to get 100%, well, close to 100%. You might have made a small notation error somewhere, but you'll know that your answer is right. So what we're going to do is we are going to look at some more complicated ones that take more log laws to figure them out and work from there. So this second example, it's an exponential function. We've got x in the exponent. So we can start by taking the log of both sides. So that's step 1. It's a pretty easy step. Step 2, we want to get that x out of the exponent. And now we're going to apply our log laws. And this is the place where people are going to get tempted by their log laws. Okay? You're tempted to use this log law right here. Oops. I mean, this is a good log law, right? Because this is the one that takes the exponent and moves it out in front. And so I see x as an exponent, and we will be very tempted to move that x out in front at this moment. But the important thing to look at in this formula is this formula works if this exponent is to the entire base. And in our question, the x is an exponent only to the 3. You can't multiply 2 times 3 together in this case, because order of operations say the exponent has to happen before you multiply. And so we can't use this log law yet. But we can use the log law that says, inside my log, I am multiplying 2 times 3 to the x. And if I use that log law first, saying when you multiply, you add, that breaks those 2 up. And now my x is an exponent to the entire base inside of this log. So now I can bring out the x in front. And we have succeeded in step 2. We've used our log laws to get x out of the exponent. Once we're done this, we need to use algebra. You want to get x by itself. So I'll keep the x log 3 on the left-hand side. I'll subtract log 2 on both sides. And now if I want to find out what x is, I would divide both sides by log 3. Again, we go to our calculator. I'm going to use my fraction button to write it as a fraction. Otherwise, you'll need brackets around the top and brackets around the bottom. So I've got log 5 minus log 2 divided by log 3. 0.834. A quick check to see if that actually works. I'm going to hit my store button and store it as x. And my original equation was 2 times 3 to the x 2 times 3 to the power x. Is that equal to 5? It is. So then we know we're right. The last example that we're going to look at has an x on both sides of the equation. The idea is the same. This is an exponential equation. We're going to start by taking the log of both sides. Once we've taken the log of both sides, we'll go to our log laws. Am I allowed to bring this x minus 1 out in front? Yes, because it's exponent to the entire thing. And notice how I put that x minus 1 in front in brackets. Because it's the whole thing comes out in front multiplying by the log 5. So a common mistake is forgetting those brackets. And same thing, is the exponent there to the entire base inside that log? Yes. So we can bring out the 2x plus 3 log 3. Now I talked about it a little bit earlier, how important to recognize what's a number and what's just a function. Okay? Log 5 is a number. It's asking 10 to what power is 5? It's somewhere between 0 and 1. Log 3 is a number. It's asking 10 to what power is 3? It's also a number somewhere between 0 and 1. Since these are numbers, what can you do with numbers outside of brackets? You can distribute, right? You can multiply those out. And the reason I point that out is later on you're going to get questions that look like this. And you are going to be tempted, even though it's not true, to distribute. What am I distributing on the top here? I'm just distributing log. Is log a number by itself? No. Log is a function. You can distribute numbers. You can distribute variables because variables are representing a number. You can't distribute a function. Where have we seen this before? Right? Our alpha plus beta formula. We have these huge alpha plus beta formulas. You can't just distribute the sign to each one. But in our case here, since log 5 is a number, we can multiply it through and we'll get x times log 5 and minus 1 times log 5, which will just be minus log 5. And since log 3 is a number, we'll get 2x log 3 and 3 times log 3. And we get this big, long looking expression. And now we have to get to our third step, which is solve for x. Now, if you had an easier question with nicer looking numbers. So here's an easier looking question. I'll just take the log out and say, if I had 5x minus 5 equals 2x times 3 plus 9, how would you solve that? You put your like terms together, right? You'd move your x's to one side of the equation, you'd move your numbers to the other side of the equation, and then you'd divide to solve. Well, we're going to do the same thing, but our numbers aren't nice. Like here, putting the 5 and the 9 together is going to be easy. Here, putting a log 5 and a 3 log 3 together is not going to be as easy. And in fact, what we're going to do is we're going to put our x's on one side of the equation. So I'm going to subtract that 2x log 3 from both sides. We're going to put our numbers on the other side of the equation. So I'm going to add log 5 to both sides. Does it make sense that I've got numbers on one side and things with variables on the other side? Now, normally you could put like terms together and add them, but in this case, the adding isn't so easy. So what we're going to do instead to get x all by itself is say, there's an x in this term, there's an x in this term. What could I do that gets one x all by itself? Factor. So we have a common factor here. If you factor out that x, this is what would be left inside. This side still has 3 log 3 plus log 5. And now, inside the brackets is a number. So if we divide both sides by that number, we get the following expression. If we take that and type it into our calculator, again, I'm going to use that fraction button, or else I have to put this entire thing in brackets and this entire thing inside brackets. So I've got 3 log 3 plus log 5 divided by log 5 minus 2 log 3. Enter. 3.51. Okay, now we're going to find out, have we made a mistake along the way, or is this correct? So I'm going to store that as x. Oh, I did make a mistake in typing it in. I see it right now. Can you see that I forgot to close a bracket? Okay, that's going to be bad. So let's retype it. Let's go inside here. Insert a bracket. Oops. Minus 2 log 3. And then I have an extra bracket that I don't need now. Okay. Does that look better? Yes. Does that make a difference in our answer? Oh, yes. So it's approximately negative 8.35. Now, we would have seen our answer was wrong. This is a good idea. Let's say we thought this was our answer. Okay? And we hit the store button and stored it as x. When we go to check, is our answer correct? This is how we would do it in this question. We go to our original question, which is 5x minus 1 equals 3 to the 2x plus 3. So when I type in the left side, I go 5 to the power x minus 1. Oops. I type that in. I get 56.77. When I go to the right-hand side of my equation, I say, well, what's 3 to the power 2x plus 3? And I notice, hey, wait a minute, these answers should be the same. Because my original equation was 5x minus 1 should equal 3 to the 2x plus 3. And they don't match. But when we try our second answer, there's our second answer. I'm going to store that one as x. And now when I try 5 to the power x minus 1, and I try 3 to the power 2x plus 3, we do get exactly the same number. Whew, that could have been really embarrassing to get it wrong again. And then we'd have to go and find our mistake again. So they can be frustrating equations because you do all that work and your answers don't match up. And then you redo the question again to find out. Now, for me, can you see how frustrating this would have been? Because all of my work here was right. I just typed it into my calculator wrong. So if I would have redone the whole question thinking that my work was wrong, and it was my typing into my calculator that was wrong, that could be very frustrating. So we got to be careful. We got to be careful when we type things into our calculator. We got to be careful while we're doing our work, because redoing this could take a lot of time on a test. And the nice thing is we can check to see if we're right in the end. So we're going to take some time to work on the exercises on the back there.